Hey guys, Jason here. In today's episode, we're going to go over some of the different 3D toolpathing strategies in Carveco Maker and Maker Plus. To start out, I'm going to drag in a 3D relief from the clip art library. We're just going to use this Chinese dragon, and I'm going to set the depth of this dragon at 1.5 inch. And we're just going to paste that down. Now that I have my relief model imported, I'm going to open up my 3D toolpaths. In order for us to show the different 3D toolpath strategies, we have to have it set to whole relief. If we set this to automatic boundary, when we select our finishing tool, which we're going to use a 1/8 tapered ball nose. I have this 1/8 tapered ball nose set at a 1/4 inch step down, 0.25, and an 8% step over. So if we have automatic boundaries selected, we only get the Rasta and the Rasta X and Y strategies. Whereas if we select whole relief, we get a few more. We also get the spiral and the spiral in a box strategy. And I'm just going to go over what the differences in these toolpath strategies are. In Basic Maker, we have the 4 classic toolpaths, but in Maker Plus, we have an additional Rasta and a Rasta X and Y toolpath. These 2 toolpaths come from the old PowerMill software. They were originally considered advanced toolpaths because they were multi-threaded and 64-bit. The classic toolpaths originally had a size limit. They would sometimes run out of memory, and so they had these more advanced toolpaths that were 64-bit and multi-threaded. However, Carveco has since fixed all of those issues with the classic toolpaths, and they've actually enhanced those toolpaths so that they are faster than the PowerMill ones. The other real difference is in the multiple Z passes. The classic toolpaths have the multiple Z pass option, whereas in the PowerMill ones did not. Now, to understand what multiple Z passes is, normally you would never use this option because you have a roughing tool, and I don't have a roughing tool selected. And if I were to calculate this toolpath right now with our 1/8 tapered ball nose, and I'm going to simulate this toolpath, and if you see, guys, since we didn't do a roughing pass, the finishing bit is coming all the way down through that material and trying to run its finishing pass through the depth of that material in one pass. If we select multiple Z pass, it's going to break our finishing toolpath option into Z slices so that we can remove this material in slices as we get down to our 3D object. With multiple Z passes, we have to define where the bottom of our cut is going to be. We're going to start at 0, which is the top of the material, and then our model is 1.5 inch thick. So we're going to go down 1.5 inch, or a negative 1.5 is going to be where our finishing Z is going to be. And now if I calculate this, and this is going to take a minute because it's going to do a full pass for every step down of the bit. And I had my step down at 0.25 inches, so it's going to make those layers 0.25 inches until it gets down to the 1.5 inch that we designated in our finish Z of our multiple Z pass. Okay, and now if we reset our simulation, let's delete that one, and we're going to start our simulation over. We can see now that our finishing bit is taking off layers, and it will continue to make its way down. And you can see as it comes down, it is also doing its finishing pass. It's cutting that 3D relief out. Okay, and when it's finished cutting out, it's made it all the way down. And that's what the multiple Z passes option is for. But normally you would just use a roughing bit to remove all of that material. But you can do it that way as well. Okay, going back up to our toolpath strategies, our Rasta toolpath, because the Rasta toolpath goes from left to right, back and forth, a lot of times you're following the grain of the wood. You're either following with the grain of the wood, or you may have your board turned with the grain north and south, and so you may be running against the grain of the wood. You can change your angle to run at a 20 to 45 degree, and this will change the Rasta direction to run diagonally across your material. material. That can help with not running with or against the grain of the wood. If we change to the Rasta X and Y, the Rasta X and Y strategy is very similar to the Rasta strategy, except it just adds an up and down strategy. Now, because it runs two strategies, this is the longest toolpath strategy and takes the most time. If we run our simulation, you can actually see from the simulation that the bottom edges are a lot cleaner. When you add that second pass, that's the other direction, it helps clean a lot of that up. Another great toolpath strategy is the spiral toolpath strategy. The advantages of the spiral toolpath strategy is because the bit is always moving in a circle, you're never with or against the grain of the wood. Because the motion is continuous, the bit doesn't pick up and have to move over. This is one of the most efficient toolpath strategies and the fastest of the 3D toolpath strategies. However, if we use just the basic spiral toolpath, when the toolpath strategy finishes, you can see that because the toolpath strategy is a spiral, when it reaches the edges of the material, it stops. It does not continue past to get these corners. Now, to solve this, we have spiral in a box, and spiral in a box just adds movements at the end of this spiral path to get these corners. If your model will fit inside the spiral toolpath, it's the fastest and most efficient toolpath strategy in Carveco. The alternative, spiral in a box, adds moves to get each of the corners. And if we simulate that toolpath strategy, it also gives us one of the best finishes. I highly recommend using spiral or spiral in a box when available. And if you need to use the Rasta toolpath, try using that at a 45-degree angle. And one last trick, guys, if you want to use these advanced toolpaths but you don't want to have to cut out the entire waste material, a trick for that is to draw a box around your relief and go to model and crop. Now you can run the whole relief and this advanced toolpath strategies, and it will cut just what's inside this box. And if I run my simulation, you can see that the original material reference starting point didn't change, and so it kept our original material size but only ran the toolpath inside the box that we cropped. And that gives you the access to those advanced toolpath strategies without having to cut all the extra waste material. If you thought this content was valuable, please subscribe, hit the like button, and share this with someone. Thanks, guys. We'll see you on the next one.